Next topic is indicator diagram or a PV diagram. Indicator diagram or a PV diagram is a graph between the pressure and the volume of a system undergoing the operation. That means if we take pressure on the y-axis and volume on the x-axis, then a graph is called the indicator diagram or the PV diagram. And the area under the PV curve and the volume axis is the work done. If we take at volume V1 and pressure P1, this is the one of the point, initial state suppose P1 V1, and after that its volume becomes V2 after some time and pressure becomes P2, then this area will be the work done by the gas or system. And a point on the indicator diagram represents the states. That means this point A has the state P1 V1. Similarly, the point B has the another state, say P2 V2. Therefore, point on the indicator diagram represents the unique state in terms of the pressure, volume and temperature of the system or the gas. And the curve on the indicator diagram represents a unique process. There are the different thermodynamical processes. For example, one is the isochoric process. It is a process for which volume remains constant. That means there is no change in the volume, that is delta V is 0. And if delta V is 0, it means work, which is the integral of pressure into volume, it will be also 0. So in isochoric process, there will be no work. Similarly, another process is isothermal process. In this, temperature remains constant. In isobaric process, pressure remains constant. In adiabatic process, the process is taken so fast that there is no exchange of heat, and we say delta Q equal to 0 for the adiabatic process. Here we should remember that if delta Q equal to 0, then we can't necessarily say that process is adiabatic. For an adiabatic process, for each and every step, there will be no exchange of heat. So we take an elementary dq 0 equal to 0, then we say it is a adiabatic process. And this dq equal to 0 for whole process, then the process is adiabatic. Similarly, a cyclic process is the process in which the system reach from initial state and covering the other states so that final state is same as the initial state. In that case, temperature is same, and because temperature is same, so we can say there is no change in the internal energy. Therefore, in cyclic process, initial and final state is same and the change in the internal energy is 0. Graphically, if we draw the isochoric process, then pressure and volume axes are shown here, and the graph having a vertical line on the y-axis, then we say this is a isochoric process. Here volume is same and work done will be 0. Similarly, if we have to draw the isobaric process, in that case pressure is same, so there is a line parallel to the volume axis, so it is a isobaric process. Similar way, if we draw the pressure volume graph or the indicator diagram for a isothermal process, then this is a curve and it is isothermal process. Similarly, if we draw the graph for the adiabatic process, it will be similar to the isothermal, but it has higher slope. The graph is for adiabatic process. And indicator diagram for the cyclic process will have initial and the final position same. So this is the initial and final position same, and this process is called the cyclic process. Let's take one of the question. The first law of thermodynamics is based on, options are the law of conservation of energy, law of conservation of heat, the law of conservation of work, the equivalence of heat and work. And as we have earlier stated that law of the thermodynamics is based on the law of conservation of energy, so option A is the correct option.